Welcome to the glass plate. In this exercise we're going to take a look at conversion of hydraulic energy into electricity. And we're going to compute what the biggest waterfall on Earth, the Victoria Falls, could give us as electric energy if we assume that all the water coming down is converted into electricity. These falls are impressive. The drop in height is about 100 meters. And the amount of water flowing is huge. It's almost 1100 cubic meter of water per second that splashes down. Suppose we would be able to turn all this gravitational energy into electricity. So we would turn the Victoria Falls into an electric power plant. How much would it be? To give you a ballpark number, standard modern power plants fire by fossil fuels have energies around 2000 megawatts. How much would this be? Okay, this is a steady state system, so we can set up an energy balance and do that in steady state, so that the EDT equals 0. Obviously energy is flowing in, energy is in principle flowing out, and there is a productional term, meaning that we convert gravitational energy into electricity. And we would like to know how big this one is. And thus we need to know how much flows in and out. This can be written as the flow rate times the energy concentration. And I need to fill in here how much energy a cubic meter contains. Well, I can do that easier per kilogram. So I turn this into a mass flow rate. Mass flow rate and then the amount of energy per unit of mass. It has potential energy, GH. It has kinetic energy. It has pressure energy. These are the amounts that come in. What goes out? Well, the same mass flows out, so I don't need to index the mass flow rates. I can use the same. These are the same. If you really want to be sure, set up a mass balance and in steady state compute what flows in and what flows out. Okay, it has 0 potential energy because it's down at ground level. It has the same kinetic energy because by and large the water coming in, velocity here, must be the velocity here as all the water has to go through, and it has pressure energy. This one, let me use another color, can be scratched out against that one. What about the pressure? Well, both are at atmospheric pressure. It's an open fall. So the pressure here is atmospheric, the pressure here is atmospheric, so these can be scratched out. And what I'm left with is that the production of energy that you could maximally get if everything is converted is the mass flow rate, which is the density of water times the volume flow rate, times the difference in potential energy is GH. And if you compute this, turn this into a number, let me peek on my piece of paper, you will have 1150 watts, which is a small power plant if you compare them to the fossil fuel plants. So don't do it. It's anyhow a bad idea. Okay, Niagara Falls, huge falls. What the Victoria Falls mean? What if we looked at Niagara Falls? Now, so if this was, let me do that in blue, the Niagara Falls. What would change? Well, the height would change. They are not that big. They are only 51 meters. The flow rate is, however, bigger. It's more than doubled. Same analysis will hold, just different flow rates and different heights. How much would you produce? Well, this is roughly doubled, this is roughly halved, so it will be kind of the same number, which it is. It's 1200 watts. So also here, Niagara Falls turning into power plant. It's too little to do, and they're gorgeous, so we are not going to do it. Obviously, if you would, you wouldn't even get this number. They're all kind of losses. Probably you wouldn't even reach half.